Hello everyone, this is Skanda Rajaratnam regarding the machine learning project. Looking for the opportunity evaluation according to a project in 5G, 6G telecom industry is the O-RAN technology, Open Radix Network. Mainly this project name is Predictive Maintenance and Predict Maintenance of Network Functions, Network Equipments for the O-RAN, mainly the radio access network. Regarding the project, is there is a problem to select the model? Yes, in the O-RAN telecom industries, network equipment such as base station, antennas, and 5G other core networks, network function, plays a crucial role in delivering reliable and high quality communication service to customers. These components are susceptible to wear and tear, environmental factors, and other malfunctions, which can lead to service disruption and impact customer service. Does anyone care about it? Yes, mainly stakeholders, they are the investors. If there's performance is bad, then we lose the customers, then there's an issue. Using the AML model in this telecom industries, we can get uninterrupted communication and the performance, so it should be taken care of by AML. Can ML help to solve this? Yes, ML can play a crucial role in solving the problem of predictive maintenance for network equipment in the O-RAN telecom industry. ML techniques can be applied to the vast amount of data generated by network equipment to extract valuable insight and make accurate performance. What is the business understanding using the CRISP design method? First, business understanding. Identify the business objective, assess the current situation, determine the project scope. The primary objective is to improve the reliability, uptime of the telecommunication network by implementing predictive maintenance for network equipment. Determine the project scope, define the project specific components and type of network equipment that need to be covered under the predictive maintenance initiative. Second design concepts, data understanding, data collection. Historical data on network equipment performance, maintenance records, environmental conditions, and other relevant parameters need to be collected. After that, we have to do the data exploration and let the data collect the data, understand the structure. Then we have to prepare the data for modeling and training. So data cleaning is the first one. It's not easy. We have to handle the missing values, outliers, and other inconsistent data issues. We had to select the features. The feature in the second one, we had to collect the right features to get the right modeling and training. Data transformation, perform the data scaling and normalization, or the transformation to ensure all features are in the same scale. Modeling next. Select the right algorithms, machine learning and supervised learning, unsupervised learning, and regression, linear regression, a lot of algorithms available, so it depends on the technology and we have to get the right algorithm. Then model training and validation, so we need to know how to split the data and evaluate the model performance using the appropriate metrics. Evaluation, assess the model performance, Evaluate the predictive maintenance models on validation set to determine the accuracy, precision, recall, and other relevant metrics. Deployment, next concept. Implement predictive maintenance. Deploy the trained model, ML model, into the telecom infrastructure to monitor network equipment in real time and generate maintenance alert. Monitoring, continuous monitoring. We need to be continuously monitor the predictive maintenance system performance and gather feedback from maintenance teams to ensure it meets the desired objective. So applying machine learning to dynamic radio resource management in the O-RAN telecom industries can be achieve the desired business impact and meeting specific objective through the implementation of ML powered solution. Define success. What is the define success? Success is not depend on the improving technical metrics, but also in how well the ML-driven approach aligns with the business goals and delivers benefits. Quantifying the expected business impact involves defining outcome and output metrics that demonstrate the value of the ML system. So outcome and outcome metrics are increased in the overall capacity of the O-RAN network. Output metrics can be resource utilization, inference reduction, quality of service. Identify the factors. What are the factors potentially relevant. The arrangement of base station and their coverage areas affect resource allocation and handover decisions. Infrastructure RF, weather condition, network load balancing, cell traffic balancing, quality of service, user traffic patterns, network conditions, and device types, depend on the Android, Apple, and other devices. The solution validation plan. What is that? So briefly, I'm going to describe the concept of how it uses ML. Employing machine learning techniques, the solution creates a self-adaptive and data-driven radio resource management system. The model analyzes real-time data, predict future resource demands, and make dynamic adjustment to optimize resource allocation, reduce interference, ensure efficient use of radio resources. How we will execute a series of iterative experiments to validate the proposed solution concept. Iterative experiments will be data collection and processing, feature engineering, model selection and training, model evaluation, and real-time solution, feedback, loop continuous, performance monitoring, interpretability and explainability. We can go on, and mainly I like to just go with a couple of things. Data collection and processing, collect real-world data from network equipment, user devices, and other relevant resources, spanning a significant time period of capture diverse network condition and traffic pattern. Process the collected data, handling missing values, outliers, and normalize the features to ensure consistent scaling. We have to select the right features. That is very important. And model selection, model evaluation, how we are evaluating the model, what the metrics we are using, the precision, accuracy, FN score, and convolution metrics also can be used. It depends on the algorithm. Real-time simulation, implement the simulation environment to handle the real-time nature of the radio resource management system. And as feedback is a learning, and performance, how we are doing how that model is doing. We have to check the performance and get the feedback. Then deployment field testing, we have to deploy this model and test it. ML design, the high machine learning system design. 3 ML system design decisions for the dynamic radio resource management in the oil and telecom industry. ML algorithm selection, model development and real-time updates, model deployment and real-time updates, and explainability and interpretability. For the resource allocation traffic prediction task, I will choose a combine of supervised learning algorithm and regression for resource allocation and time. Supervised learning algorithms, there's a resource regression for resource allocation and time series forecasting for traffic prediction. Explainability also need to be, because if there's an issue, then we need to explain how the model is behaving. So in the oil and telecom industry, decision related to the radio resources of allocation can have significant effect on network performance and user experience. Algorithms like linear regression and decision trees provide a clear insight into a resource allocation decision. Operators can understand why certain resources are allocated to specific cell or user and other potential buyers. Let's go with the potential risk in production. When deploying a proposed machine learning model for dynamic radio resource management over a network, several issues may arise. Some possible source of issues: real-time latency, overfitting, data quality and drift, outliers, scalability, and privacy concern. First, go with the real-time latency. Real-time deployment introduces latency constraint, and the model must make resource allocation decision promptly. Data quality and drift. In production, the incoming data may contain noise, missing values, or other anomalies that were not in the training data, and data distribution may change over time, leading to a concept drift. The model needs to be adapted to a new distribution to maintain accuracy. Next, overfitting. During model deployment, the system might become too specialized on the training data, resulting in overfitting. Overfitting could lead to a poor generalization and decreased model performance when deployed in production. There's some outliers and anomalies. Outliers and rare anomalies in the production data might not have been adequately represented during model training. And scalability. There is a production system often handle large-scale data and numerous simultaneous users. The model should scale efficiently to handle the volume of incoming data and traffic. And resource allocation decisions for multiple sales and users. Then privacy concerns is very important. This is ethics and governance. Deployed production environment raises security and privacy concerns, ensuring that sensitive data is properly handled and access to the machine learning system is secure and necessary. Thank you.